Hello everyone! In this video, we're going to discover the different lab tools and the use of each. Let's start. Before entering the lab, there are some safety rules to follow. First, you must wear a lab coat to protect your clothes from chemicals. The lab coat must have long sleeves to protect your arms. Hair must be tight to avoid its contact with chemicals or catching fire. Some reactions release harmful gases, so your eyes must be protected by wearing goggles. The direct contact with chemicals might be irritant for the skin. That's why gloves must be worn. Now you are ready to enter the lab. Let's discover the lab tools together. Test tubes. Test tubes are used to hold chemicals while experimenting. They are useful during qualitative tests. During an experiment, the test tubes are placed on a rack. Labeling test tubes is essential to track the content of each tube. In this experiment, the scientist would like to detect which solution is acidic, solution A or B. Already the scientist knows an indicator color that changed non-acidic solutions into pink. So he took few milliliters of each solution in a test tube and added a few drops of the indicator color by using a medicine dropper. As solution A stood colorless in the presence of the indicator color, so it's acidic, and solution B turned into pink, so it's non-acidic. In another example, the scientist would like to know if solution C contains starch. Already he knows that starch will turn iodine from brown into dark blue. So he replaces a few milliliters of solution C in a test tube. Then we'll add a few drops of iodine. As there's a change of color from brown to dark blue, this reveals that solution C contains starch. Beaker. A beaker is a container used for holding various liquids, as it's useful for mixing chemicals. Some of them are heat resistant, so they are used to heat liquids. In this example, the scientist mixed sugar and water, stirred them by using a glass rod, and heated the mixture. The graduation in a beaker enormously varies between two marks. In this example, it's increasing 50 milliliters, so it gives an approximate value of the volume. Due to its large diameter, we might add or remove many milliliters without observing a slight change of liquid level. Accordingly, due to absence of accuracy, the beaker is not helpful for measuring precisely. A glass rod. A glass rod is used to manually stir solutions. Conical flask. A conical flask is a container with a narrow neck, which allows mixing by swirling without splashing out. The conical flask can be closed by using a stopper, but do never close the conical flask when you're mixing, especially with a chemical which releases gas, to avoid the increase in pressure and then explosion. The narrow neck of the conical flask is helpful when you need to collect the gas released by a chemical reaction. So, you can use a stopper with a delivery tube. In this experiment, the scientist is testing the kind of the gas released. Both a beaker and a conical flask are containers. When do we use each? A beaker has a wide top, while the conical flask has a narrow neck. In a beaker, mixing needs a stirring rod, while in a conical flask, mixing will take place by swirling. When we're mixing in a beaker, there's a possibility of splashing out, while there's no splashing out when we're mixing in a conical flask. The beaker will stay opened, while the conical flask can be closed by using a stopper. The gas from a chemical reaction will escape when it's done in a beaker, while in a conical flask, the top is closed by a stopper with a delivery tube, so the gas is recuperated. Cylinder. A measuring cylinder is used to measure volumes of liquids. The volume is read from the bottom of the meniscus. Accordingly, the eye level must be at the level of the bottom of the meniscus to have an accurate reading. In a measuring cylinder, the volume changes from one graduation to another in order of 1 milliliter, which makes it relatively accurate. But few drops of liquid might be added without changing the level. From another point of view, a slight error might take place when the level of liquid is between two graduations, especially when the diameter is larger. A pipette. A pipette measures and delivers an exact volume of liquid. Due to its narrow diameter, the bottom of the meniscus is clearly shown, which makes the volume the most accurate. A pipette is accompanied with a filler, which is used to fill and pour the liquid. It's placed on the top of the pipette. It serves as a vacuum source for filling reagent through a pipette, and also help control the flow of the liquid. In front of me, a pipette of 25 milliliters. This allows us to transfer the total available volume, or getting benefit from the graduation to transfer a specific amount. Medicine dropper. From its name, it's clear that the medicine dropper is used to transfer few drops of a liquid. In this example, the scientist is adding few drops of iodine to detect the presence of starch, and here, few drops are added to fix the volume of the liquid. A digital balance is used to accurately measure the mass of a substance. Spatulas are used to scoop small amounts of chemical powders from their containers. A watch glass. A watch glass is used to recuperate things. It can be used to hold the chemical on the balance to weigh its mass, as it can be used to cover the top of the beaker. In this example, the watch glass is used to recuperate the small rocks. Right now, use the digital balance, watch glass, and spatula to weigh an exact mass of 5.12 grams of sugar. Pause the video to write the procedure, then play it back when you'll be ready. On the balance, we put a watch glass to hold the sugar. It's clear that the balance showed the mass of the watch glass. This mass is not needed, so we press the bottom tar to start from zero. Accordingly, the mass of the watch glass is not included in the result shown on the balance. Now, use the spatula to weigh 5.12 grams of sugar. A volumetric flask is a flat-bottomed bulb with an elongated neck calibrated to measure a definite volume of liquid. Volumetric flasks come in different volumes. In front of me, a volumetric flask of 250 milliliters. When the liquid will reach the calibration mark, this means that we reach an exact volume of 250 milliliters. The narrow diameter of the neck makes the meniscus clearly shown, and just one drop will change the level of the liquid. Look how the scientist set his eye level at the bottom of the meniscus to have an accurate reading. A filter funnel is used to safely transfer a liquid from one vessel to another, especially when the receiving container has a narrow opening. Plastic wash bottle, mainly used for rinsing glassware and for dispensing small amounts of distilled water. It is mainly used when adding water for dissolving or for chemical reactions. How to prepare a solution by dissolving 3.24 grams of sugar in an exact volume of 250 milliliters of water. Let's set our materials. We need a digital balance, a spatula, a volumetric flask, a stirring rod, weighing bottle, filter funnel, a beaker, and a plastic wash bottle. Put the weighing bottle on the balance, then press the bottom tar to set the value at 0, so the mass of the weighing bottle won't be included. By using a spatula, weigh 2.24 grams of sugar. Transfer the sugar to the beaker and rinse the weighing bottle for many times in order to collect the whole mass of sugar. Add a small amount of water to the beaker, then dissolve the sugar by using a stirring rod. Use a funnel to transfer the mixture to a volumetric flask. Rinse the stirring rod and the beaker for many times to recuperate the whole amount of sugar. Then transfer water to the volumetric flask. Then rinse the funnel. Swirl the mixture very well to be sure that the whole quantity of sugar was dissolved. When the volumetric flask is half filled, there is enough space to mix the water and sugar, but if water reached the neck of the volumetric flask, There will be no available space for mixing. Accordingly, part of the sugar won't be dissolved and will settle down. When you are sure that the whole quantity of sugar is dissolved, add water to reach the neck of the volumetric flask. Use a medicine dropper to add water slowly until the bottom of the meniscus will reach the calibration mark. Pay attention, one drop will change the volume. Now, mix the solution transversely for many times for homogenization. Mortar and pestle. Mortar and pestle are used to grind substances into powder or slurry. Look how this tablet of vitamin C is turned into powder. The other lab tools are formed from glass, while the mortar and pestle are formed from ceramic to avoid breaking. Sometimes we need to heat the mixture, so we use Bunsen burner. The Bunsen burner will produce flame. That's why we use a metal gauze to absorb and spread the heat of flame. Accordingly, glassware will be protected from cracking and breaking. A hot plate. A hot plate is a flat surface device used for controlled heating. The hot plate is branched to electricity and harmless than the direct flame produced by the Bunsen burner. The thermometer. The thermometer is used to measure the temperature. It exists as digital form which shows the temperature as numbers, or the traditional thermometer which contains mercury or alcohol. The liquid will proportionally expand due to heat and show the temperature accordingly. Evaporating dish. An evaporating dish is used to evaporate excess liquids. It's formed from a heat resistance material such as ceramic. Look how water evaporates in order to recuperate salt alone. Hot materials such as an evaporating dish can't be held by hand to avoid burning. Look how the scientist is removing the evaporating dish by using a pens formed from wood.